You know, the AI boom is everywhere. It's powering everything from the chatbots we talk to the promise of cars that drive themselves. But behind all that, there's a hidden revolution happening, right down at the microscopic level. It's a fundamental shift in how computers actually work, and it's what's making all this possible. So today, we're going to unpack that shift, the move from electricity to light.
Okay, so to really wrap our heads around this, let's just start with the sheer scale of what's going on here. I mean, AI isn't just some little niche thing anymore. It's become the main engine of growth for the entire semiconductor industry for the next decade.
And the numbers, they're just staggering. We're talking about a market projected to skyrocket to nearly $1 trillion by 2030. And this isn't just coming from giant data centers. No, this is being fueled by everything from the AI PC on your desk to the humanoid robots we keep hearing about.
But there's a problem. This incredible growth, this race towards smarter and smarter AI, well, it's running straight into a wall. There's a fundamental physical limit, a hidden bottleneck that could seriously slow this whole revolution down.
Well, it's not a lack of processing power. We are getting really good at making incredibly powerful AI chips. The problem, the real bottleneck, is how those chips talk to each other. It all comes down to communication.
So for decades, right, we've relied on these tiny copper wires to move data around. But as you can see right here in this chart, copper works great for really short distances, like on a single chip. But it just loses efficiency fast when you try to send huge amounts of AI data over more than a few centimeters. The signal gets weak, and it burns way too much power.
So to break through this copper wall, engineers are turning to a totally different and, frankly, a much cooler solution. They're replacing that flow of electrons with actual beams of light.
And, when you put them side by side, it's not even a contest. This new approach is better in every single way that matters for building these massive AI systems. Optical interconnects, they use way less power, they generate less heat, and they can carry a ton more data over much longer distances. It's a complete game changer.
Now, this all comes down to a technology called silicon photonics. And we're not just talking about using fiber optics between computers anymore. No, we're talking about building these tiny little superhighways for light inside the computers themselves, right on the silicon chip. But here's the thing. Inventing this incredible light-based technology, that's really only half the battle. The real magic, the key that unlocks all that performance, is in how you package it all together with the AI chip.
Think about it like this, like a Formula One race. What good is having the world's most powerful engine if your pit crew is slow and clumsy? You're still going to lose the race, right?
And this image just nails it. This is the new reality. Advanced packaging is that high-performance pit crew for the AI chip. And you can see it right there. Silicon photonics is now a critical member of that crew. It's what determines how fast and efficiently the entire system can run. This brings us to the key innovation that makes this whole thing work. It's called co-packaged optics, or CPO. And it's a really simple but powerful idea. You take the component that turns electricity into light, that's the optical engine, and you place it as close as you possibly can to the AI processor.
So here's how it works. The AI chip does its heavy-duty processing. Then, right next door, the optical engine takes those electrical results and boom, converts them into pulses of light. That light then just zips through the optical fibers, and by putting those engines less than 5 centimeters apart, the results are just dramatic. We're talking about cutting power consumption by over 50% and slashing that communication delay or latency.
And I gotta stress, this is not just some concept on a slide. This is a massive, complex, global effort that is completely reshaping the tech supply chain as we speak.
Yeah, this is not one company tinkering in a lab. This is more like a global technological ballet. You've got specialized material suppliers like Corning, huge foundries like TSMC making the silicon, and then end users like NVIDIA and AWS designing the final systems. It's an incredibly intricate dance.
And just look at the timeline it takes to build a single AI server rack. A traditional copper-based system might take 6 to 9 months, but integrating these new optical components, that pushes the timeline out to 8 to 12 months. It is a monumental undertaking that requires totally new ways of manufacturing and testing.
What's really clear is that every major name in tech is deeply invested in making this happen. From the foundries like TSMC that literally build the chips, to the designers like NVIDIA, to these cool, innovative startups pushing the envelope, and all the way to the hyperscale customers like Google and Meta who are going to deploy this stuff at scale.
Okay, so we've looked at the problem, that copper bottleneck, and the solution, co-packaged optics. But let's bring it home. What does this actually unlock for the future, and, why should you even care? Well, this roadmap from TSMC really tells the story. We are right on the cusp of a bandwidth explosion. Right now, we're at what are called pluggable modules. But by 2026, we're going to see CPO enabling AI clusters with 4 times the bandwidth. And then after 2028, the goal is to have optical connections built directly into the GPUs and CPUs themselves, pushing bandwidth to levels that are hard to even comprehend right now.
And the practical impact of all this is huge. This new way of building systems, what the industry calls scale across, is going to lead to data centers that are 3.5 times more energy efficient than the ones we have today. I mean, that's a massive win for sustainability and for cost. Plus, they can be built and deployed 30% faster.
So at the end of the day, this isn't just about an incremental improvement to make computers a little bit faster. No, this is the fundamental key, the enabling technology that's going to unlock the next generation of artificial intelligence. We're talking about models and systems so powerful we can barely even imagine what they'll be capable of.
You know, what this all really points to is a fascinating shift. For the last 100 years, our entire world has been powered by electrons moving through wires. But as we look to the future, it really seems like the next century of computing and the incredible AI it's going to create might just be